This conference will now be recorded.
Good afternoon, everyone. Research is to see what everybody else has seen and to think what nobody can else thought. I appreciate your guidance, consideration, help, time, and feedback from my side. Thank you for joining the lecture series. My name is Dr. Divya, and I am the PG Scholar of Panchakarma Department of ANU Tibia College. It is a great pleasure for me to introduce our speaker today. Today, on the ninth day of the lecture series, are presenting topic on variability, probability, parametric and non-parametric test. Presented by Dr. Shriramji Girish Shankar Jyotishi sir. Just a little housekeeping. Before we get started, if you have any questions during the presentation, please type them into the chat box. I will bring them for the question at the end. Now, without further ado, we will turn the time over to our guest speaker today is by Dr. Shri Ramji Girija Shankar Jyotishi sir. He is MSc in Organic Chemistry, MA in Public Administration, PhD in Pharma Science, and a visiting professor at Mahatma Gandhi Ayurved College, Hospital and Research Center, Data Mega Institute of Medical Science, deemed to be university that is Salod, Varda, Maharashtra. Since 1st April 2015, he approved as a lecturer and associate professor and joined Shri Ayurveda Mahavidyalaya, Hanuman Nagar, Nagpur for 36 years. He approved as a faculty of Maharashtra University of Health Science, Nasik for the workshops of research methodology and medical statistics, and the member of Scientific Advisory Group CCRS, Ministry of Ayush, Government of India, member of Central Scientific Advisory Post-Graduation Committee as per the Indian Medicine Central Council. His research activities are on the exploration of the Ayurvedic principles and providing laboratory experiment-based evidence to the same, along with the study of the chemistry of Ekal Oshti Dravya and some formulation with SOP were the main objectives. And it was met by designing and performing experiment for MD IU project, and he is a co-guide of that. 76 such project has been completed so far, 22 research papers, 6 monographs in API, and the 8 articles have been published or presented. 2 PhD IU projects are being co-guided, and the other research works are he is a principal investigator in IIT New Delhi, Government of India for the standards of Gomutra and development of standard for ISM and IH in Ayush. Total monograph published is 6 in the API. Sir has establishment of central research laboratory with designing, fabrication, assembling of 20 instrument apparatus. Most economically, some of them are modifier cleavage apparatus, total solid demonstration assembly, calorimeter for the phenol measurement in Gomutra, semi-micro precipitate measurement apparatus, tracer for macroscopy. Sir has been presented as a guest lecturer and the keynote in more than 300 such as Research Institute in Jamnagar, Nasik, and etc. Sir presented as a jury member of Madhya Pradesh Council of Science and Technology Young Scientist Contest, India International Science Festival Young Scientist Contest, and the Medscape India Award 2015. Aryan Medical and Education Trust, Mumbai. Now, I would like to invite respected Sir Dr. Shriramji Grija Shankar Sir from the behalf of my department of A&U Tibba College. Thank you, sir, and welcome.
Thank you. Good afternoon, everybody. Hello, can you listen me?
Yes, sir.
Hello.
Yes, sir.
Yeah. So we would like to start the session, and the topic on which we are speaking today are one of them is variability that we are going to start now, and after this the probability will be another topic, and the parametric non-parametric test that we are going to do tomorrow. So variability. When we start with variability, we say variability here. Uh, can you see my arrow, the cursor on the screen? Hello. Can you see the cursor on the screen? Moving cursor. Can you see? Hello.
Yes, sir.
So please concentrate on that. cursor. So when we talk about the variability, that is the variation and differentiation and difference between the individuals. So in the nature we see each individual differ from the other. This is the characteristic of nature. Because we see, look at the face of our friends and all those people, none of the face matches with the other. So that is the variation, and you can understand how important this variation is. If the variation would have been not there, then we would have not survived. That is the situation, right? So, depending upon this variation, that is the variability. So, how one differs from the other, that is the important thing. And therefore, in chemical and physical system, variation is not there. Only in biological system, we see the variation. One fellow or one animal or one plant, even of the same species, everything same, they differ from the other. So, as Darwin has given in his this evolution theory, no two specimens are alike. This is the unique feature of the nature. No two specimen. Even twins, if you take, then they differ in some or the other respect. So no two specimens are alike. The statement given by Darwin in his book Origin of Evolution. Then variation, this variation, when we take one differs from the other, this is a natural and normal phenomena. This is a natural phenomenon. Will other differ from the other? That is a natural phenomena. And then we say it is essential for survival and propagation. So why do we differ from the other people, or one person differs from the other? Why? It is essential, it is necessary. If this difference would have been not there, then if you see in the further example here, in COVID-19 pandemic, some people died, some survived with infection. Survive, I'm not talking about the person who were not infected, I'm talking about the person who were infected. So those who were infected, one is the variety, one who expired, sad thing, the other who survived. In those who survived, again we see that some of them were seriously, very severely, other were having moderate moderate signs and symptoms, other were having mild, and some of them were asymptomatic. Even myself was having a mild symptomatic this COVID-19. So asymptomatic. So these are the variation, we say variation. The people of various age, some of them died and some of them survived. This is the variation. This is physiological differentiation. This is their resistance. This is their we say the resistance against disease, immunity difference. So every one of us have different level of immunity. So therefore, even those who survive, the difference which we see, and the difference that we see is some of them were severe, some of them were moderate, mild, asymptomatic, and the other were not infected at all. Means I think many of us who showed RT-PCR negative, they definitely came in contact with the other person. They were not infected. In my family itself, out of five, two were RT-PCR positive and three were negative, and both of us were having different level of severity. Myself, moderate, mild, and other one was having slightly more than that. Sir, the virus also not only human being or the
Hello.
other animals, but we see that even the virus also mutated.
Hello.
Hello,
Sir, sorry to interrupt you. Sir, your slide is
slide is
not moving.
cursor is not moving. This yes. Okay. Uh, can you see the cursor now? Can you see the cursor? The virus also mutated. So, can you listen me now? Hello, hello. Hello, can you listen me?
No, sir, your slide is not movable. Not.
Can you listen me?
Yes, sir.
Can you see my slide arrow on the side?
No, sir.
So what some I am listening some disturbing sound from your side. Can you see the slide now? arrow.
Hello. Sir, your slide is visible, not movable.
Slide is visible. Can you listen me?
Yes, sir.
Can you see the arrow moving there? Arrow. Last point. The virus.
No,
Can you
sir.
see the arrow there?
No, sir.
Can you see that? So just now I talked about variation in human being. Now see the virus itself is taking the care. The variation it is developing, it gets mutated. Why it is getting mutated? The variant which we say for its survival. So it is also the variation with the time it is showing that it gets muted. That is also variability. So in the past virus and the future, the present virus, and in future what we are talking, they are also showing the variation. It is for their survival. The more stronger they are, we are developing the immunity, and they are developing something which will be against its strength against our immunity. So mutation takes place, and that is called variant, and that is for its survival. Now I go for the second slide. Now types of variability when we say, so we divide them into three major types. A is the biological variability. Biological variability means the variability which we have just now seen. We have seen we see its type. So one is the biological variability. This is natural and normal phenomena. Means natural thing which we have seen, that variability will be there, but within certain limit. The variation means different people are having their different height at the same age, but the difference is there, but it is within certain limit. So therefore, we say it is not natural and normal. So when this variation is there, it is a biological variation. So now among these individual variability is there, that is variability from person to person. Different people have different weight of the same age, same age they have different heights, different blood pressure, but that is within certain limit, and we say it is natural and normal. So from person to person, it is called individual variability. But in the same person, periodical time to time in the morning, if you see, then blood pressure will be different. In the evening, blood pressure will be different. And in Ayurveda also, we say morning is the kapkal, evening is the vaskal. So accordingly, physiology also changes. So that is a periodical variability that changes in the same person depending upon the time. So, and here now, third one, class of availability. If you see same age of girls and boys, so in this case, the samples as a class sample from the girl is taken, sample from boys are taken, then we see that same age, that mean height of boys is more than mean height of girls. Similarly, mean weight of boys is more than mean weight of girls. So this is called the class of variability. This varies from group to group, means and a different type of group. But even if you take children of the same age from Maharashtra and Punjab, then they will also. But this will again be this thing natural and normal within certain limit. In all case, this will be within certain limit. If crosses the limit, then we call it abnormality. Otherwise, it is normal thing. Then
हेलो
sample
गुड
variability.
आफ्टरनून सर
Hello,
हेलो गुड आफ्टरनून
hello.
सर आपकी जो स्लाइड है सर वो विजिबल तो है बट सर वो मूव नहीं कर रही है जैसे आप
नहीं
बोल
नहीं
रहे हो उस हिसाब
नहीं, तो यहाँ पर आपको सैंपल वेरिएबिलिटी दिख रही है.
नो सर नो 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 सर
So the
ओनली
slide which
फर्स्ट
is
पेज इज विजिबल
first page is visible. Oh, I
यस
am
सर
showing the second page here. See, this means you are seeing the variability. Variability, each
यस
individual
सर
differ
यस
from.
सर
Now I am changing the slide. Can you see the change slide?
नो 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 सर नॉट नो सर
But could you see some difference on the screen?
यस सर नाउ
So
आई कैन सी
now could you see type of variability?
यस सर आई कैन सी
So I'll keep it like, and in the corner there is series of slides are shown. I'll show you this one only. Okay.
ओके सर
So,
ओके सर
okay. So in this, I was talking about the biological variability. This is we have different type of variability. So biological variability, natural and normal phenomena. Variation from one person to another, from time to time, from class to group, and sample variability. This is a natural and normal, but within certain limit. If this limit is crossed, then we say the person is not normal, abnormal. So that measurement is required, and we have to calculate. We use that thing in statistics, right? So biological variability is not a natural, normal, and within certain limit. And this is of four types here. Individual variability, that is from person to person, right? So we have different persons are there, same age, same sex, have everything same, but still their height will be different, weight will be different, blood pressure will be different. Even though all of them normal, sugar level, cholesterol level, everything differ from each other. Some may have the same, there is no problem. But that difference will be within certain limits and it is a normal and natural. The second periodical variability, that is in the morning your blood pressure will be different, in the evening your blood pressure will be different. So from call which we say time, it varies from time to time in the same individual, but again within normal limit, within certain limit. So we call it a natural phenomena and it is periodical variability. Then class and group variability. If there is a group of girls and group of boys of the same age group, then we'll see the mean height that height of boys is more than height of girls. Weight of boys is more than weight of girls. This is a natural thing, right? So this is called the this varies from group to group, called as the group or the class variability. Then sample variability. If you take a sample from the same population, two samples randomly of the same category from the same population, then if you find out the mean of one sample and mean of other sample, you will find that there is difference in the mean though both the samples are from the same population. Therefore, this is called as the sample variability and this is again natural and normal phenomena within certain limits. So all these type of variability are called as the biological variability. They are natural, normal within certain limit. If they cross this limit, then we go for the real variability. So second one is the real variability that is beyond a natural limit. Here we talked about natural limit. They are beyond certain limit, beyond the natural limit which is there in the nature limit. So this is now abnormal of subnormal. Either it will cross the upper limit, then it will be abnormal. If it will cross the lower limit, it will be subnormal. This is hyper condition. This is hypo condition. So this is called the real variability. So this is not only the case of sickness, but then the thing is that when the real variability is there beyond the limit, normal, abnormal, or subnormal, this is under the influence of external factors. This is happening, something which is unnatural is there, some external factor is there, therefore the thing has crossed this thing, and that factor is maybe infection, sickness, anything, or some different behavior, something. Therefore, this change has taken place and the person is normal or subnormal. Then it requires need to be treated or outcome of treatment. If this is a sickness, right, then we are required to treat the person, or then we are giving some treatment, then also it will cross that abnormal limit from within the normal limit, right? So it is crossing the limit. So it may be the outcome of the treatment also. It may be because of sickness, it may be because of the treatment. So next we go for the next slide. Type of variability, continuing it. The third, two we have seen, the third one we see experimental variability. So experimental variability is not variability in the sense, real sense, it is error in the real sense. So when we are doing some experiment, you repeat the experiment, once you may get one result, twice the result may vary slightly, right? So this is the error we are committing. It is different that we suppose we are taking pulse of a patient. Once you take it, it will be different, and it will be different at the other time. That is the periodical variability of the patient really, right? But we are doing some experiment, and sometimes we get now one reading. Other time when we are repeating, we are getting other experiment. For example, blood sample is taken from the patient, and you make it into two parts. And if you take reading from the blood sugar in first sample, the same sample divided A part and B part, there may be slightly different. This is actually the error because the blood contains same amount of sugar and you are getting, so we are that is our hence error. So this is called experimental variability and error may be there. Sometimes we call it human error also. So this is error in real sense and should be minimized or eliminated totally. So it should be, it is our error, therefore we must minimize it. So this human error or the experimental variability, we can say it is again of the different types. And the first one is called as the observer's error. Error by the observer. So it is observer's error, and we call it. This is because of the observer is when again this observer's error. One who is observing the thing, it may be of two types: subjective error or it may be objective error. Subjective, when the patient is sitting before us or we are doing some survey, we are asking questions, so untrained interviewer when a doctor is there, somebody is there, and he is taking he is reporting a case paper is noting there, and he is asking the question to the patient. That particular manner, he should be, first thing is the doctor should be very friendly with the patient, right? Otherwise, other things, maybe their problem may be there. That patient may be having some fear. If the child is there, he may be feeling that doctor may inject him, injected to the problem will be there, or therefore certain types. So this is when you are asking embarrassing questions should never be asked. Otherwise, answer may not be problem. And similarly, STD and then income and so many things. We should have a particular technique to get the right answer, because the same type of question may be asked by police inspector also, and same type of question may be asked by the doctor also. So if this person with the inspector will be talking in another manner, and with doctor he will be talking in another manner. So interviewer must be properly trained how to ask the question. Otherwise, with your question, the reply may not be right. So this is called subjective error, and this is the mistake we are doing. Therefore, the person before us, subject sitting before us, is doing an error. So we should be properly trained how to ask the question. And this is the experiment. We are doing the experiment, and this is error we are doing. So we should try it in some way that we are committing minimum error. Then other is the objective error. Objective error, untrained observer. Untrained observer. When you are reading and taking reading from the mercury type of blood pressure instrument, then parallax type of error may be there. We are observing the instrument, but we are not doing it properly. We are not in position to take the correct reading that way. Second thing is that because of your behavior, how they are behaving with the patient, with that behavior, what will happen? Patient psychology may change, and because of that psychology, his pulse reading may arise. So what observation you are taking, the observation number you are counting is correct, but you have done something. We are not proper untrained observers. So the manner in which we are taking it may rise the pulse of the patient, or heartbeat may, or blood pressure, something may happen. So we should be properly trained how to take the observation, how to ask the questions. Otherwise, we are committing observer error. This must be minimized. Second is the instrumental error. So the thing is that before using the instrument, we should be able to check the instrument whether the instrument is properly working. So the weighing machine is there. Put weight on that 10 kg of weight. The 10 kg, whether it shows 10 kg, 15 kg, whether it shows 15 kg. So this is called calibration with a known thing. So we are confirmed that yes, instrument is right, then we are using. So instrumental error, either the instrument is uncalibrated or defective. It is something is wrong. Calibration means you see if there is some knob in the weighing machine which we adjust zero, right? So that is calibration. And defective, though you are adjusting, but instrument is not proper, so we cannot use it unless and until bad or replace it. So this is instrumental error. We should replace it or repair it, right? Then sampling error or error of bias, which we say. So sampling error, if we say what is the recovery rate of a disease in a private hospital and recovery rate of a disease. But if you carry out that survey in private hospital, you will see that recovery rate is faster as compared to government hospitals, or recovery rate of disease in a civil area is faster better than the recovery rate in slum area. The reason for this, the reason very simple, that in these two socio-economical condition is different, and the care to be taken, other things, diet to be taken, medicine to be taken will be different. If you go in the civil area and you just collect the data for recovery rate of the disease, this will be faster recovery will be there. And actually, when we are recovery rate of disease, means you should include slum area also, socio-economical different level also, and all that collectively will have to report it. Then it will be the correct thing. Otherwise, the error will be there, and it is called non sample error, sampling error. Therefore, sampling care is to be taken. How a sample is to be taken, what should be the sample size, that is important to avoid this sampling error, or we call it error of bias. If the technique is not proper, it is called error of bias. So those are called the bias sample. This is non-random, so the random sample should be selected. Next we go for the variability. Now this not only in statistics, not in only the modern science, they are talking about the statistics, but Ayurveda talked much about variability, and much care has been taken, and more than what we are doing today. It is more than. I'll give you one example. That today doctors say we should consume at least 2 to 3 liters of water per day. But I don't think this is right. Somebody requires 1 liter of water, somebody requires 3 liters of water. So everybody is drinking 3 liters, the 2 liters will be more. Double the quantity then required is taken 3 times the quantity that's taken. So variation. Therefore, we cannot talk like this. Whereas Ayurveda talks that a person of Pitta Prakriti requires more water, a person of Kapha Prakriti requires less water. See how nicely it has been mentioned in Ayurveda as compared to modern average and statistics says. Average rate of a person sitting in AC will definitely require less water than a person working on the sun on the most dangerous work he is doing. So how we can say 2 to 3 liters of water and on an average, this misleading this thing, and that Ayurveda has taken much care that we are going to see in this slide. Different prakriti. Even if everything we are doing the same, we are sitting in the AC room or we are roaming in the sun, then Prakriti is different. Therefore, our behavior will be different and the requirement will be different. So, according to Prakriti, different variation is Prakriti to Prakriti variation, we would say, not person to person, but in person to person will be because the level of various doshas will be different. Even if the a person belong to same Prakriti. So variation from Prakriti to Prakriti, variation from person to person depending upon the level of doshas. See, the level of doshas. So if we talk about the different Prakriti, it includes, I think, level of Agni, Mandagni, the Tibragni, all these things, Samagni, Vishamagni, all these things will be there. So person with Pitta Prakriti will be having slightly Tibragni as compared to person having Kapha Prakriti. So the variation according to this is all physiological variation which Ayurveda has mentioned, which is not mentioned. They will say this much of diet is required, but for a person with Agni will require more diet, with Mandagni less diet. All this Samagni proper diet, all these things will be there. So the variation we are talking about here, right? Then different dhatu sharta is there, and this is the variability as mentioned in Ayurveda. Different dhatu sharta is there, and these are the few examples I have taken, etc. Many other things you know better than me, right? So this variability and the things that I will have talked and their behavior. Now, apart from the Prakriti, they have their behavior that is Manasik, which the modern science never talks. Manasik, Sattvic, Rajasi, and Tamasi behavior. Manasikta will be there. And this is the Deha Prakriti. This is the Manasik thing. Sattvic, Rajasi means the thinking, their thinking idea, their action according depending upon for the same thing. A person from Sattvic will have different thinking. Rajasi will have different thinking. These will have different thinking, and they will act accordingly, and accordingly the physiology will also differ. So see how nicely I will talked about the variability, very nicely, better than what I think today we talk in science. And variability has been also considered with respect to not only with the person, their prakriti and mansik, but the variability has also mentioned with the kal and desh. This is with the climate, various geographical area, and how it differs. That also talked about means a person belonging to particular dish should consume medicine, the products from that dish only, even if the person shift to other dish temporarily. He should consume those things that much. That I'm working on one PhD product on this thing. So that dish variability with dish is there. Variability with kal is there. So with this kal, even we say kal, we have a different type of thing. Means vale kal, tarun avastha and vrinda avastha. That is also three avastha, and that is the kal or dinacharya, ratricharya, and rutucharya. So how this kal differ, and Ayurveda has clearly mentioned very nicely how we should behave, what we should consume, how much we should take the rest, and how much comes to be done different kal. So they very nicely it is mentioned in this Ayurveda. So here where Ayurveda has talked much about variability than what today we see in modern science. It is now it is applicable to food also. The person Then Kal and Desh, now it is applicable to food also, that is Ahar, different type of Ahar. Has been mentioned, depending upon the Shatrasatmak Ahar, different rasas are there, and Laghu and Dhruv Ahar is also there. So variation Ahar is there, and medicine also with Kal and Desh. So which I already explained here, a person require medicine or diet and belonging to particular dish, and Kal we talk about seven Kal. So it depends upon the Kal, the variation, the variability with the Kal is mentioned, and variability with the accordingly. This is very important thing which now the WHO and others are thinking, this part which I have given here. Accordingly varying Rutucharya, Dinacharya, Ratricharya, and further here now WHO is thinking, and personalized medicine are mentioned. So now WHO is talking about the personalized medicine, whereas Ayurveda has talked about this, mentioned about this since beginning. So this all is the variability have written in short. You know it much more than me what I am talking. So variability is given here. Now we shall go for the next slide, and this variability in statistical sense now. Now when we talk about the statistics, it is always we want the things in numbers, in figures, so that we can calculate it. Therefore, now we talk about the variability in statistical sense. Observations are required in numerical values. When we say something is less, that is more, this is not sufficient. We should be able to express it in numbers. For example, somebody asks me how much time it will take for me to go to railway station. I will say it's near only. You will reach there in short time. No, this has no meaning. But actual numbers means these 2 kilometers will take by vehicle. If you go, it will take 5 minutes, 10 minutes. So here you can see the variation that things which when we are talking, numerical values are required. So also the variation. Therefore, observations are required in numerical values, and so also the variation also are required in figures. So therefore, when we are going to see it further, along with this, what we require, variability in figures, type of variability we want to know, and that we have already seen earlier. The scale in which we are measuring we are counting or measuring the variability. So the scale, we have four types of scale. One is the nominal scale or categorical scale. So in that we mention the thing, describe the thing quantitatively, that is male or female, like that. So that is a scale, nominal or category we say. And another is the ordinal scale. So ordinal scale, we say we talk about the rank, the person stands first, this person stands second. So this is their order we are telling. So the person who stands second is not half of the first. Right? On the first is not double of the first. Right? Two are running in a race. Suppose first the one who is not on the first line, he crossed the distance in 10 minutes, and somebody crossed the distance between 10 minutes and 5 seconds. So this is the second one. It may be 10 seconds also. That will also be second if there is nobody between them. It may be 11 minutes. But if there is nobody between the two, the 10 minutes and 10 minutes will be first, and 11 minutes person will not with 11 minutes will be second. So, but there is nobody between them. So the second and one, there simply it tells the order, but they are not comparable with um, uh, with each other, right? Then how many times one is this? This is, and then we have the ratios. We have the interval scale. So when we talk about the temperature, say 30 degree and 60 degree. So 30 degree, 60 degree is not double of 30 degree. Mathematical the figure appears like that. But because the zero is not absolute there. Zero is the absolute zero if you talk about, then absolute zero stands at 273. 273. So it is 30 degrees actually 303 degrees, right? And 60 degrees actually 33 degrees. So now here the zero is not absolute, therefore thermometer, the temperature is not an absolute scale. But interval we can measure actually the difference between the two we can measure. So scale is also important. And next one is the called as, which is not mentioned here, the scale, the ratio scale. In the ratio scale, how many times one thing is more than the other. So 1 kg and 2 kg, definitely 2 kg is double of 1 kg because zero is absolute. So this way we have the scale. Therefore, when we are going to talk about the variability, the scale used for measuring or counting the variability is important. I talked about the four scales here. The type of data should also be known. What type of data, whether it is qualitative data or quantitative data. So when we are talking about the statistics of variability, we should know all these things. Then only we can work out the statistics of variability. So normal, then with this, we say normal limits can be fixed. If the variability can be worked out in statistical sense, we can say normal limit can be fixed. For example, we say that 98.6 temperature Fahrenheit is a normal one. Before up to we can consider it that to be normal. So, and what should be the height at particular weight, what should be the weight at particular age. Accordingly, we can fix the height, though it is variation. But in this variation also, we can fix the normal limit, right? So variation should be mentioned in the numerical values, and we can fix this thing. One thing, and the second level of significance for difference can be assessed. See, one person is there, another person is there, one group is there, another group is there. So there is difference between that two group or two persons.
Hello. Hello. Sir. Where?
Vary
This
from
conference
other
will now be recorded.
So how these samples, how this individual in the sample differ from one another, right? So this when we are these are the major for this is called sample variability. So variation within the sample. So variability within sample, and these are the measure that is range. What is range? We talk about the lowest and the highest observation. We take 20, 30, 40, 50, 100 people in a sample, and the lowest one and the highest one reading are called the is called the range. The people are within this range, right? And this is the poorest indicator. In statistics, it has no value, right? So the range, lowest reading and highest reading between all these people are there, and this is the poorest, and it has no statistical value. Second, we go for the now what we are saying there. There is a mean value in the sample. There is a mean value, and we will find that the crowd of people, that is number of frequencies, are closer to the this mean value. And as we move away from the mean value, number of frequency, number of people go on decreasing. Means near mean value, more people will be there. As we move away from the mean value, number of people will be decreasing as we move away. So therefore, the limit means the lowest and the highest. Here we are talking about when they are all of them are arranged in increasing order or decreasing order. So the lowest will be first lowest will be first reading, and highest will be the last reading. In this case, in semi-interquartile range, they are arranged in the similar way, and it is divided into four parts. That is divided into four parts. Four parts means one quarter of the total observation in the first part. Second quarter is between first and second part, and third quarter between second and fourth quarter, and the last one will be the fourth quarter. So it is divided into four parts. It is the number of individuals. Suppose there are 100 individuals. So in the first quarter there will be 25%. In the second quarter again 25. But this will start from 26 to 50. In the third quarter again from 51 to 75. In the fourth quarter the person will be from 75 to 100. So it is divided into four parts. Now we'll see that the reading between quarter 3 and quarter 1. This is higher reading, quarter 1 is the lower reading. Between this, the number of people are more than the quarter within quarter 1 and fourth quarter. Here people are much more concentrated. But again, if we divide it by 2, still shorter will be there, and within this shorter range, range will be very short, but number of people will be more because it will be around mean. Therefore, same we call it quarter one minus quarter two divided by quarter one divided by two. So we get semi interquartile range. This actually shortens the range with higher number of frequencies, which I told you just now. So that is the, again this is in statistical sense has no meaning. Therefore we go for the next, and it is called the mean deviation. Mean deviation. Now mean of the deviation of all the observation from the mean. That is, we are having a sample of 100 people and we have a mean of all these 100 people. Now within these 100 people, we see that somebody may have the reading same as mean, or people may not have, because the mean is the calculated value. Some people may have the value, or nobody may have that mean value. But other people will be lying around. Some people will be less than mean value, or some people will be higher than mean value. So we see actually how one reading differs from the mean value. It may differ by 1 unit, the other may differ by 2 units, other may differ by 1.5 unit on the positive side, or in the negative side. Positive side means higher than mean, negative means lesser than mean. So they will differ like this. So what we are going to do, we are going to add all these differences. We are going to add all these differences, and then we are going to divided by number of observations. So here is the equation, summation of modulus of x minus x bar divided by n. So summation means total, which I told you that we'll add. So we'll find out the difference. Each of the x is the each observation. So we have 100 observations. So 1, 2, 3, whatever is the height or weight of this person is there, we have the mean. So we will 100 times we will separate first reading minus mean, second reading minus mean. So we will have 100 differences, right? We will these parallel lines, this line, these are not the brackets, parallel lines. We call it modulus. So we add all these differences. Some of the differences will be in plus, some of the differences will be in minus. Those who are less than. Okay. But we'll ignore the sign. Otherwise, they will cancel each other. We'll ignore the sign and we add them. Right? We will add them. Therefore, these parallel lines have been taken and divided by total number of n, and total number of observation, that is n. So we get the mean deviation. It means it is the mean of the deviation of all the observation from the mean. It is this thing, right? Next, but this is also not that much useful. Therefore, we say go for the next very measure, that is standard deviation. And this is the main thing. If standard deviation would have been not there, then statistics would have been not there. This is the, as we say, the soul of the person, Atma. Right. Similarly, it is the same thing. Without standard deviation, nothing could have been done in statistics. It describes the distribution of frequencies. Frequencies means number of observations. It describes the distribution around mean. So mean value of a sample is there, and around mean, how various observations, various frequencies are lying. How are they lying very close, or some are lying far away? So how they are lying in, as we move 1 unit, 2 unit, 3 unit on the positive side or negative side, less than or more than of the mean value, then how much observation are there in the first, second, third, and fourth step, as we say. So how that is done, it determines, then further it determines confidence limit, that we are going to see confidence limit. This we will see actually later. Confidence limit, samples, we calculate sample size also depending on the standard deviation. From standard deviation, we calculate the sample size. From standard deviation, we find out the confidence limit. I will speak out one word around it. When you observe a patient, you observe a patient means you measure either pulse or blood pressure or sugar or whatever you, either within the normal limit you say that the person is normal or abnormal. Suppose you say it's normal. So when you say normal, with that reading, statistically the person is normal, but that reading may be more for that person, right? So the person is not normal. But readings are normal according to the text. According to text, the readings are normal, but they may be more for its original reading, right? Therefore, because of this situation, when we say the person is normal, actually we are correct to the extent of 95%. When we declare the person is normal, that means 95% chances are there that you are correct, and 5% chances are that you may be wrong. The person may be abnormal, still we are calling it abnormal. So you are wrong to the extent of 5%, right? So this is the actually we therefore we call it a confidence limit. So when we declare a person to be normal, we have 95% of the confidence that we are right and 5% we may be wrong. Therefore, so that is determined with the help of standard deviation. And sample size can be calculated with standard deviation and standard error also. All these are required actually. Sample size is required when you are selecting a sample, right? Then standard error is required when you are applying the test of significance, parametric, non-parametric test. So all these things are required. So this, as I told you in the beginning, it is the soul of statistics. Atma, it is just like Atma, right? So the formula for this sigma stand for standard deviation, small sigma is equal to under root summation of x minus x bar whole square. X, as I told you, individual observation, and that you have to subtract mean of that group, right? So you will suppose you have 100 observation, so you will have 100 such values, right? You add them, you square them individually, then add them together and divide it by total number of observation minus 1 and find out the root or under root of that, and that is the standard deviation. That is standard deviation. So that we have come up with what is standard deviation, how it is calculated, what is its use, we have seen. So next we go for the further measure of variability. So now we have seen sample variability, the variation in the sample. Now we go for the population variability. So this is the now we the population variability. Variability in the population. Previously we have seen variability in the sample. Sample is a representative part of a population. Sample is a population part of the population. It represents the whole population, right? It represents the whole population. So now, but that was the measure of sample variability. Here we talk about the population variability. So which are the measures? Standard error of mean, right? Standard error of mean. So represented by SE X bar. Various samples. Now we take many samples, say 30 sample, 100 samples from the population. Previously we were talking about individuals in the sample. Now we are taking samples. Each sample may have 30, 40, 50 individuals, and we are having 30, 40 samples. From the population have their own mean. So each sample from the population will have their own mean. One thing. Mean of these means. We have as many samples, we have so many means. So find out the mean of this mean, and that is called as the population mean, represented by mu. And standard deviation of population. Now we have a population mean, and how various samples differ from this. And if we find out the standard deviation of this population from mu to x bar is the sample mean of individual. Is standard error, that is called the standard error of mean. It is useful for comparison between a sample and population value. So we have, it's a sample we are having, whether it belongs to a particular population or it differs from the population, whether the sample is normal or abnormal as compared to population. This sample is compared with the population, and we find out standard error as here we have seen in the previous formula x minus x bar. Now here we see x bar means there are so many samples we are having, various samples, each of them are having their means, and we represent that. So you have a one population mean, right? Mean of mean. Now again you subtract population mean from this value. So if you are having 30 sample, you will have 30 such values, differences, and it is squared, and then it is total is taken divided by n minus 1. The n minus 1 is the number of samples. Then we find out the square root, and that is x SC X bar means standard error of mean. Now, practically it is not possible to have so many samples from the population and taking the reading in each sample. So alternatively, we take only one sample and find out the standard error by this formula. With this, that you take one sample, find out the standard deviation as we have seen in the previous slide, sigma. So and divided by the root of n. It is divided by root of n is number of individuals in the sample, and we get this same value. Therefore, from one sample, find out the standard deviation and divided by root of n of the individual in the sample, and we get the standard error of mean. And this is the then standard error of mean of the population. Now, this is the one measure. Second measure is standard error of difference between mean. So when you are treating a sample in your hospital, so you will have to that sample is the sample of sick person or whatever it is, right? So you will have to compare that sample with the population to show your result, whether they are progressing properly or not. But it is not possible practically because you want the population values which we don't have. Therefore, to make it easier, we take two samples. One is experimental, another is control. So this is standard error and of difference between means. Therefore, this is the sign for that, and it is designated by this, denoted by this. If sample are taken in pair randomly, right, from the population, we take the sample randomly, mean of difference, and we find out the difference. So now you take so many, this is now assumption. Imaginary, you take so many samples randomly in pair. Sample x1, x2, right? A, xa, xb, 1, xb, x2, 2, like this in pair. And then you find out the difference between mean of these. So you will have, as many pairs are there, you will have so many differences will be there. And then you find out the standard error, then that will be the actually standard of difference between. But practically, this is not possible. This is not possible. So therefore, we take only two samples, not so many samples, as we have seen in this case. Only one sample is taken here instead of so many samples. Here also we take only one sample, only two samples instead of so many samples. So here we take two samples, we find out the combined standard deviation from the two samples. Both the samples will have their own standard deviation. So we find out the combined standard deviation of both the samples, and that value is placed here, and then it is under root, this is under root 1 minus n1 plus under root 1 minus n2. That means one sample, number of individual in the ones, and not necessarily that both of them will have the same, one or two maybe less or more, no problem. So under root we are taking 1, that is 1 by n1 plus 1 by n2. Add these two, reciprocal of n1, reciprocal of n2, add them together and find out the root and multiply it by C is the combined standard deviation of both the sample, and you will get a C x bar 1, x bar 2, that is standard error of difference between two samples. How it is useful? It is useful when you take two sample in your experiment. One is trial, another is control. Now control, as you know that we are giving some, and trial we are giving some treatment. In control, either it is placebo or standard medicine is there. Then we measure either the weight or blood pressure or whatever it is there we measure. So after that, the course of treatment, we find the difference between the two samples. Now whether this difference is a biological difference or it is a real difference, that we judge by applying the test of significance, suitable test of significance, and therefore applying the test of significance, we need this value. This value is needed here. So when you are doing the experiments, two rules are there: whether if your drug is working or it's not working. Therefore, when that if it is working, then it will be a real variability, and if it is not working, then it will be a biological variability. And with a real variability means your drug, your treatment is effective. If it is not working, then that means biological variability will be there. That will be shown us by the test of significance, and test of significance requires this value. Therefore, we find out the combined standard deviation of these two groups and multiplied with the root of reciprocal of n1 plus reciprocal of n2, and we get this value. And we apply, we use it for test of significance to differentiate the two groups. The third is the, so here we will, these two were for the quantitative data. These two were the for quantitative data. In case now, where we measure the blood pressure of weight or height or sugar or whatever it is, right? That is a quantitative data. Now, you say you have given treatment to say 50 individual of one group, and to other they are a placebo. Say, for example, cough and cold is there, right? Cough and cold is such a thing which, after say a week or 15 days, recovers by itself. Suppose you are using some medicine in your treatment, so it may recover. Hello, hello, hello. I'm listening some voice. Hello, 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 hello. Yes, I'm listening some voice. Some problem is there. Is there any problem?
No, sir. Okay, sir.
Ah, right. Shall I start? Hello.
Yes,
Shall I
sir.
start?
Yes, sir.
Yeah. So suppose you are having some 50 patient in your trial group and 50 patient in your standard or control group, right? Now, suppose it is a case of cough and cold symptoms. So cough and cold get recovered after a particular duration. There is no sometimes it will be less, sometimes it will be more. But suppose you are having some medicine, some treatment, which in which if you are using that medicine, then the recovery rate may be faster. So you fix a time that after say 4 days, 5 days, 6 days, number of patients recovered in control group, and in the same day, number of patients recovered in the trial group. So this number of patients, right? So here we say number of patients, we can calculate the percentage of patients recovered in one group within that particular time, and number of patients recovered, percentage of patients recovered in the second group, right, in treated group. So here, where the number is more, where the percentage is more, so there will be some difference. In one, it may be 50% of the patient recovered, in other it may be 40%. So whether this difference of 10% is biological or real, again we have the type which we have seen. Biological, when we say, means it is not natural and normal. It's not because of the drug. But if it is science test of significance says it is real, means we will say some external factor is operating. That means our treatment. Our treatment is there because of this. The 10% of the patient recovered here more. 10% of the patient more. 10% of the patient recovered here, and there is 10% are less. Therefore, in that case, we apply the standard of standard of proportion. Proportion, right? Standard error of proportion. Here one word is missing, right? Standard error of proportion is missing here. Just I'll copy it here. Right, now it's okay. So standard error of proportion, standard SCP. So in this case, very simple formula like this only, very simple. It is under root q divided by n. Under root PQ divided by n is the number of individual in the sample. Number of individual. We take only one sample. And here we are, what is this SCP? For comparison, as we have seen in the case of standard error mean, comparison of population and sample. Here also sample and population comparison, proportion of sample and sample proportion and population proportion. So we take only one sample, and then PQ. What is PQ? P is the positive character and Q is the negative character. Right? Positive character means recovered, negative character not recovered. Right? So here we can say that in general, suppose population proportion in 8 days recovery or population proportion is say in 7 days it is 50%, right? And you have taken only one sample, not two samples. No control is there, only treatment is there, and you are giving some treatment. In your case, within these 7 days, recovery rate in your case is say 60%, right? So population value is known to us, so we'll compare the sample value with the population value, and this will be useful for us to find out the significance level of significance. So this is the for comparison of sample proportion with the population proportion. So this is SCP. When the population value is known to us, we simply take only one sample and we compare it. But when these values are not known to us, right? Not known to us, then we go for the standard error of difference between proportion, right? And that is generally required. How it is required? We are having two groups. One is the control group, another is the experimental group. Control group may be placebo, control group may be standard one, something like that, right? So you might do the control, you might be giving standard treatment, and to your experimental you are giving a experimental drug, right? Treatment. So in this case, whether your drug is as good as the standard, it is better than the standard, or it is less effective than the standard. Or other way, if it is a placebo, so whether your drug is better than the placebo, that we can take care, because every time we don't have the population proportion, therefore we simply take two values, two samples, and one is standard and one is control, another is experimental. Then we find out the standard error of proportion and standard of difference between proportion using this formula. Standard error of proportion is p1 minus p2. Right. This is not the values here. It is simply standard error of difference between proportion. This is denoted. This is denoted by this. Right. Is equal to root PQ. I'll tell you what is PQ. PQ again within bracket reciprocal of N1 plus reciprocal of N2. 1 by N1 plus 1 by N2. This you have to take the total of this, reciprocal of this, and multiplied by P and Q. Now what is P and Q? P is, as we have seen here, PQ. These are the small p and small q. These are the capital P and this is a combined P of both the groups. Right? There is another formula. So this capital P, combined P, as we have seen, combined standard deviation, but this one is out of root and this is inside the root. Right? Because when we take the standard deviation, we in the formula we are having the root. Therefore, we are keeping it outside the root and this is inside the root because here we are not taking the root earlier. So P is the combined P of proportion of the percentage of both the group, that is P1 plus P2 divided by 2. So we get the P value, capital P value, right? And 1 minus or 100 minus P. If we're talking in terms of percentage, then 100 minus P is equal to Q, right? So we take this value of the combined samples, and with this we calculate the standard error difference between proportion. In test of significance, we require this value, and there we apply test of significance will tell us whether it is a real variability or the biological variability. If it is a biological variability, then we say that our drug is not effective. Or if it is an again biological variability, in case of standard drug, then we say it is as effective as the standard drug, right? So this way we use this value, and it is important, one of the measure of variability. Now next we go for. Yes. Now the variability is over. Next we go for the probability. Right. Some 4 5 slides are still there. I think we finish it in time 350 something around that. So probability. Probability is a chance. Probability means chance. Suppose we have to meet someone. We generally talk whether this time we meet. What is the possibility that we are going to meet, we can meet that time? So probability is the chances of happening or not happening. So when we are going home, so there can be an accident also. So what is the probability of accident on the road? Yes, on all the things are there. So maximum we talk about the probability is 99% chances that we'll reach safely home. So we are taking 1% risk on the road, right? Or 2%, it depends. But therefore, the same probability is calculated in terms of statistics. That is calculated here, right? So the probability is the chance, and we calculate this chance in our experiments that the patient is recovered. So what is the probability that the patient recovered because of the treatment, or what is the probability or probability that the patient might have recovered even without treatment? So calculate that probability. What is the probability that the drug will work, and what is the probability that it will not work? Right? So we calculate when we are appearing for examination, we work hard for this. So again, what is the probability that we get through the examination or not? So this is the probability, the chances that we calculate here is especially in case of treatment, whether the probability that whether a null hypothesis is to be accepted or rejected, what is the probability of null hypothesis to be true, or the drug is working, what is the probability that the recovery is because of the drug, or it would have happened by itself. So that is the importance of probability. Every event in nature is associated with uncertainty. What will happen? Nobody can certainly say that this will happen, right? Nobody, even if we are using so many scientific methods and today these things are creating season now. So they forecast for the heavy rain and that nothing happens. Next day we see bright sun. Or sometimes we say tomorrow it is going to be bright sun, we see heavy. But it happens many times what they say. Many times it happens, say 50%, 90%, 60%, 75%. It comes to be true. So the probability that what they have forecast, what is their forecast, what is the probability that it will be true. So we can, so every event in nature is associated with uncertainty. The patient is coming to know what is the probability that the patient will recover or may survive or may die. So we calculate the probability, right? So uncertainty is there whether the patient will survive or die, right? So uncertainty. Hence, the chance that it will happen or it not happen, will happen or not happen is calculated in proportion, right? In terms of percentage. Proportion means out of one, and percentage means out of 100. All of us know it. So it is calculated in terms of proportion means out of one. So, right. So that is called probability. That is the probability. So it is calculated. And the formula for this is P, that probability is equal to number of event divided by number of attempts. Right? Number of So if we calculate the probability, how safely I will reach home today from my office, from my schedule. Right? So when we are the number of accidents, we are meeting the accidents is the event. And number of times we are moving on the road is an attempt, right? So what is the probability that accident will take place? So how many accidents have taken so far on that road when we move, right? And how many times we moved on the road, on that road? So number of attempts, right? When we are appearing the examination, what is the probability that we get through the examination? So number of events, how many times you got through the examination, out of how many times you attempted for the examination. So this way, event number of event divided by number of attempts is called the probability. And the next is the under different situation. It is calculated according to following laws. Now this is a general formula, right? But depending on the situation, we have various laws. According to those laws only, we can calculate the probability. So when say first law is the addition law of probability, addition law of probability for different. This is applicable when this is applicable. See, when suppose a child is going to born, right? The child may be male or it may be female. So what is the probability that it will be a male child? What is the probability that it will be a female child? Right now, or when we are treating a patient, the chances, the probability the patient may survive, the patient may recover, may die or may survive. The probability, right? So we calculate probability for that. Now these two things and further more things are there. They are mutually exclusive. If a male child is born, that female child is not born. Simultaneously, this thing cannot happen. A person survived means he or she did not die. So these are the, if you are meeting to the accident, means you are not safe. If you are safe, means you are not meeting the accident. So these characters are mutually exclusive. So when we are calculating probability for mutually exclusive event, the probability of each event is added for calculation formula. Each is added. That totals one. So if you add the probability of each event, which are mutually exclusive, the total will always be equal to one. And in fraction few for few, and each of them is having their probability in fraction point something point something point something. Total of them all will be one. If you multiply it by 100, then it will be out of 100, and total will be 100. Right. So example, probability of getting one few cards from playing cards. Now suppose we are having playing card in our hand, right? And we are wishing that a card should I should get an ekka, right? So there are four ekkas, right? There are four ekka, and if I say any one of the ekka, if I get any one of the ekka, means if I get one ekka, that means other will not be there. One ace, another will not be there. I'll get only one. So one ace, if one ace is there, so that is one card of my wish, an S, right? So an S of a particular color. So the probability is 1 out of 52 because there are total 52 cards. So probability of getting one S from all these 52, so the probability is 1 by 52. Suppose I say if I am happy if I get any of the S of any color. So there are four S are there in the 52 cards. So in this 52, what is the probability that I'll be happy? I'll get any card. Anyone? So that will be 1 by 52 plus addition law of probability. 1 by 52 plus 1 by 52. This way 4 times we are adding and we are getting 4 by 52. Right? 4 by 52. So 4 by 52. So there, what is the chances that 0.077 probability is out of 1. This is out of 1. If I multiply it by 100, that will represent 7.7% probability that I get an S, because there are 4 S. If I get any one, then chances are there out of 52 cards. So probability is 0.007 for getting particular card of any color. I am talking about as this is applicable to a particular card, maybe king, maybe queen, maybe jack, any one of them will be there, because there are 4 in out of 52. So this is the probability of getting particular card of any color, right? Of any color. Whereas only particular card, a particular card, the probability is 6 months. Since we are having 4 cards, 4 different colors, the same type. So 4 by this is the 4 by 52, and that is, so here we are adding the probability of each of them, because these are mutually exclusive, right? These mutually exclusive. So if I get one, I am not going to get other. So mutually exclusive color. And then there are total 52 cards. There are total 52 cards, 4 by 52, 0.077. If you multiply, there are, because there are 13 set of each color. 13 set of each color of 13 cards. So 0.077 multiplied by 13 is equal to 1. So that comes out to be 1, as I told you. It totals 1. Right. This way. Now, next we go for the next. Now multiplication law of probability. Multiplication law of probability. Here, when the events are not mutually exclusive, they are neither mutually exclusive nor associated. They should not be associated. I'll give you the example associated now, but you could understand what is they are not mutually exclusive. Then one thing can happen with the other thing. In this case, the previous example, one thing could not happen with the other. Either this will happen or that will. That here both the things can happen. Right? Here both the things can happen. So this is applicable when these things happening events are not mutually exclusive. Because suppose blood group of a person, a child is going to born, the blood group may be A, B, AB, or O. These are mutually exclusive because there will be blood group of only one, A or B or AB or O, right? So these are mutually exclusive. But other group X, RH positive and RH negative. So RH positive is mutually exclusive for RH negative, but A is not mutually exclusive for plus or minus negative, right? So these two things, A plus or A minus can be there, B plus or B minus. So these two events are not mutually exclusive, right? But and then second term I am talking about they are not associated. They are associated. Associated means here that a child may be there, okay, a child may be there, and color blindness may be there. Right? These things that happen together, they are not mutually exclusive, but they are associated, because only children are males are color blind, females are not color blind, because it's related to XX chromosome and XY chromosome. So XX chromosome and female, they are not color blind, and male there is only one X chromosome. So there are probability of this thing, color blindness. Therefore, we say that color blindness is associated with sex, right? Therefore, this law cannot be applied there. This law cannot be applied because it is associated. Whereas RH positive and A group, these are not associated, they are not mutually exclusive. Therefore, it can be applied there. The probability of each event is multiplied, and that totals again 1, and in fraction for few, if of it, example, birth of male child with RH positive group, right? So male child with RH positive group. So what is the probability of male child? It is 1 by 2.5. Probability of getting a male child or a female child is 0.1 by 2, right? Sorry, 1 by 2, that is 0.5, right? And what is the probability of RH positive? It is 9 by 10. In population, we see 90% people are RH positive. So it is 9 by 10, right? 9 by 10. So therefore, the probability of getting a male child with RH positive is 9 by 20, and that is equal to 0.45, right? So probability of getting a male child with RH positive group is 0.45. So here we are multiplying it. When these two are not associated, they are not mutually exclusive. So how the combination will be there? For the combination, we are multiplying it, and the probability we are getting means it is 45%. This is out of 1. Therefore, it is 0.45. You multiply it by 100, you get the percentage 45%. Right. Next, further, for a female child, same thing I am repeating here for female child. For female child, RH positive probability, female child with RH positive is again 0.45. Right. So this is 0.45. This is 0.45. Right. For a male child with RH negative, right, RH negative, it is probability is 0.05. It is calculated in the same manner as it is calculated here, 0.05. And for a female child with RH negative will again be 0.005. So here 0.45 this one, 0.45 this one, and then 0.05 this one, and 0.05 this one. If we add them together, we get equal to 1. That is, if we talk in terms of percentage, 45%, 45%, 5%, and 5%, that is equal to 100%. So we get this thing. So this is the probability of a male child with RH positive. This is the probability of a female child with RH negative, positive. This is the probability of a male child with RH negative, and this is the probability of a female child with RH negative. So we calculate the probability like this by using the multiplication of probability. Now this one binomial law, binomial or polynomial law of probability. Now this is very interesting. This is the, of course, all of these are interesting if we are understanding them, if we are using them, if we are trying to understand them. So here now the binomial law for bi or poly events. Bi or poly events means here birth of a child. It is a bi, means male or female will be there. In case of the some events, three type of events may be there, right? For example, passing the examination, or getting failed in the examination, or getting say, allowed to give some exempted part, you have to appear for some other part, but you are promoted to other class. This third category will be there. So similarly, two events may be there, three events may be there, four events may be there. So this is which we are talking about the bi or poly events, right? With bi or poly attempts. So now here we say that we talk about the two types of events. Means A plus A. One event we name it as A, another event we name it as B. They are definitely mutually exclusive, right? They are mutually exclusive. So, and two attempts are there, right? So suppose A is a boy and B is girl, right? The probability A is the probability of getting a boy child and getting a girl child. Probability B is the probability. And there are two attempts, means parents are there, they have a first child and they have a second child. Now what is the combination? What will be the combination? Either both of them will be boys, or both of them will be girls, or one of them will be boy, another will be. Only three combinations are possible. Only three combinations are. With this simple algebraic equation, we can understand it. Understand that we are calculating actually the probability. So when you reopen it, everyone of know that a square plus 2ab plus b square. So either both of them are boys, or both of them are girls, or one of them is boy and another is girl. Again, two here because either the girl will be elder or the boy will be elder, right? So that we are going to see illustrate. I am going to illustrate in the next slide. Only two slides after this, and then will be over. So we will finish it in time, right? But tomorrow's thing will be larger. It is a very big thing, right? Simple thing. Now, example: if P of male child is zero point 0.5, as we have seen, 1 by 2 means zero point 0.5, right? Probability of a male child is zero point 0.5, and that is A, and female child is zero point 0.5, and that is B. Then the in two attempts, two issues, then the probability of various combination will be, right, zero point 0.5. See, A square is zero point 0.5 square plus 2 into zero point 0.5, A is the probability of boy, into zero point 0.5 plus zero point 0.5 B square, zero point 0.5 square. See, this is the, if the probability of this is different, if the probability that thing we write for other events, right? So point. So what is this? This is 0 point, and here we write it as square. See, 5 square, it is 0.25. See, for this one, I have written it here. So this is 2 into zero point 0.5 into zero point 0.5. That is equal to 0.5 here, right? And plus again here. So we got this is the probability of two males, probability of one male and one female. So probability of getting in two attempts, probability of getting one male and one female, that is two children of opposite sex is more. And probability of getting both the male or both the female is less. And if you add them together, 0.25, that is equal to 1. Now, so this thing I have demonstrated or illustrated in the sketch in the next slide. See this one. This is the first issue. Male probability zero point 0.5. It can be male or it can be female. Probability zero point 0.5. Right. So either male will be there in the first issue or female will be there in the first issue. Probability is zero point 0.5. Second issue. Now second issue. This is elder one. This is younger one. So either after getting a male child, second child may also be male, and this is the probability is zero point 0.5 again. I or after getting a male child, there can be a female child. The probability is again zero point 0.5, right? If the first child was female, then we may get again the second child may be male. The probability is zero point 0.5. After this female, second child may be female, and the probability is zero point 0.5. Right. So here also zero point 0.5, here also zero point 0.5. In each individual case, probability is zero point 0.5. Now the combination. The two attempts have been done, and the parents got two children, right? So either both of them will be male, or one of them will be male and female, right? Right, male and female. Other female and male, or both of them will be male. So this one male female, this is female male. This is now what is the probability? The thing algebraic which we have seen here, that I am illustrating here in the simple form. So probability zero point 0.5 multiplied by zero point 0.5. Zero point 0.5 multiplied by zero point 0.5. These two are multiplied. Law of multiplication is applied here, and we get the probability 0.25. Right. Here again, multiplication of this value and this value, zero point 0.5 multiplied by zero point 0.5, again we get 0.25. Here, zero point 0.5, zero point 0.5, and zero point 0.5, zero point 0.5, here we get 0.25. And same is the case in this case. So each combination we get the 0.25, 0.25, 0.25. But the thing is that if both, in this case both of them are male, probability for two males is 0.25, right? And what we have written in the equation a square, right? This is a and multiplied by this is a square. This is a square, right? And in this case, these two combinations are same combination. Only the elder and the younger, elder and younger. Either first male will be there, second female will be there, or first female will be there, or means it is one male and one female, right? So two possibilities are two AB, two this one two A and B. So two AB is there, right? This is two AB, right? Coming this way or coming this way, and again like this B square. Here we get this value B square. So this is A square plus two AB plus B square. What we have seen in case. So this simple this thing. Now the interesting thing is that interesting thing. Now we in this case the probability of getting both the male child is only 0.25. Probability of getting both the male child is only 0.25. The female child is only 0.25. That means probability of getting both the children of the same sex is only 0.25. I think you could understand this thing. Probability of getting both the children of same sex, either both male or both female, is only 0.25, right? Whereas probability of getting one child of one sex and another of opposite sex is zero point 0.5. Add them together and we get zero point 0.5 probability of it. Therefore, in this case, if the first child is male, then the probability of getting the second child is male is only 0.25, whereas 0.75 is the probability of getting the child of opposite sex. So if the first child is male, then second for a 75% probability the second child will be female, or only 25% probability that it will be a male. Right. Similar is the case in case of female. If the first is female, then only 25% chances that there will be second one also be female. Otherwise, 75% chances that there will be male. So here we see that there is a probability in this case is double than this case, individual case. So probability of opposite sex is more. Now I will try to quote one example that there are some Vaidyas who talk about, claim about the Unsavan Vidhi, and they are of course doing the thing not opposing a particular sex. So they are doing it in the in case of second attempt. So if the parents are going to such Vaidya and this Vaidya are doing some Unsavan Vidhi, then what they say that only those who are having first child, then only I can try for this. If we are having a boy, for second I am not going to test it. All right, what that is. Right. So they claim that wherever they have done this experiment of Kunzmanvidi, in 75% cases, the child was a boy and 75%. Now, this claim cannot be accepted by statistician because I already told you if the first child is female, then there are 75% chances that the second child will be a male. So that is a natural force that 75% chances that a male will be there. It is not because of their. So when we are doing some experiment, knowledge and basic knowledge of statistics is very important. If we are not taking this care, everything will be spoiled at the end, and our experiment will go in waste. Right now, next we go for the next slide, and this is now we have seen two laws. This is the last slide, right? As you can see the times, word times here. So, and then law of probability. Last we have seen three laws till now. Now we go for the fourth, and the fifth one is here. Fourth law. From the we can calculate the probability from the probability curve. The probability curve is drawn here. It is a normal probability curve, right? So there are different type of probability curve. I have taken only one example of normal distribution curve. So normal, this is called as the probability distribution probability curve. Now in this you can see if you divide this area under the area under this curve, this area, right? And according to that, say mean plus minus 1 st, one mean plus minus 1 st, that is equal to that is means this is the mean value, say, and you add standard deviation, so plus 1 st. So you are plus 1 st to the mean value when you are adding plus 1 st. That means mean height, suppose say 100 centimeters, and standard deviation is say 2 centimeters, standard deviation. So 102 and 98. So from 98 to 108, this area will be there, and we'll see that 34% of the individual probability, 30% is 34% is here, 34% point of course 13 is here. So this covers, that is mean plus minus 1 st covers 68% of the area within this. As we move away from this, probability go on decreasing, and move away from this, probability go on decreasing on either side. Therefore, we take how far we are there and what is the area. If our observation is lying here, and that means it is lying between this value, so we can calculate the probability of a particular event, whether this will happen or not, whether the patient will survive, whether what is the, if a patient is coming to us with a particular blood pressure, and then we see what is the, so here exactly we see what is the probability that the patient is normal. If we say plus minus mean plus minus 2 st, between this, the blood pressure is between this range, this is the frequency, right? Between this range, if the blood pressure say this is mean value is say 75, and 5 is the standard deviation, then sorry, the 2.5 is the standard deviation, then 18 to 70 will be the range. So we can say those patients who are having their blood pressure between 70 to 80, then we say the 95% of the patients that are normal. So the probability of each patient will be, or the person will be 95% that the person is normal. So with this area, we can simply calculate the probability. And previous laws are there, but with the observation, we plot a graph here, and we get this type of graph. This is also for normal. Other type of graph are also there. There also we calculate the probability. But I have taken this example because all our test of significance are based on this graph only. So I think you could understand how to calculate the probability from the probability curve. The last one we go for this. the from here it is 0 has been from probability curve, from probability table. Now, actually what statisticians have done, they have taken so many observations, so many samples, so many population. They have collected so many observations. And from that, they plotted this type of curve. And from this curve, they calculated the probability at various places. And those have been mentioned in the table. Tables are there. So probability tables are there. In those tables, according to their rules, how to follow them, we can see them directly. No need of calculation, nothing. We can directly see like log tables. We can directly get the value in these tables. The statisticians have calculated the probability for various places in this, and they have prepared a table. So those tables are called the probability table. In this, various probability table are as now various not only one, but there are so many probability tables. So many. I have written the name here. UND table is unit normal distribution table. This one. This is UND table. So unit normal distribution table. This has been worked by a boss. Then students test by Gossip. So he prepared a table, T table. So it is also giving us the probability. Fisher has prepared one table, F table, that is for ANOVA. So we see we are so whichever test we are applying, test of significance that we are going to see tomorrow. Fisher test, F test, right? So we see the probability in Fisher's F table, Pearson's chi-square test and R. Both he has done. This is qualitative, non-parametric. This is parametric. So he prepared these two tables. So when we are correlation, R is correlation. This is association where the two characteristics are associated. This is what is the correlation between them. So he prepared those tables. So we find out this value and find out the probability in that table. Wilcoxon's physical values tables are there. Man Whitney new test. There we find out his table, and Spearman rank correlation table is there, and Kuski values table is there. So these people, and apart from this, there are so many tables. So whichever test of significance we are applying there, we follow that table and we find out the probability whether the null hypothesis of no difference, that is the drug is not effective, is true, or alternate hypothesis is true. So we find out the probability in these tables, right? If the probability is less than 0.05, then we say null hypothesis is rejected, right? And alternate hypothesis is accepted. Null hypothesis of no difference, that we are going to see tomorrow, and alternate hypothesis of difference means there is difference between treated group and control group is accepted if the probability is less than 0.05, that is null hypothesis is true to the extent only 5%, whereas 95%. And that is, but if suppose the null hypothesis is true to the extent of 6%, more than 0.05, then we accept null hypothesis because that is actually a risk factor. When we show that if our drug or treatment is working 95% of the patient, 95% of the cases, then we say it is effective. If it is less than that, so because we are taking 5% risk, may not work, right? We cannot take risk more than 5%. Therefore, if the risk is 6%, that is null hypothesis of no difference is taken, that treated and untreated group are not differing from each other. So this way we calculate the probability and we draw the conclusion. Thank you very much for giving me an opportunity to have discussion with you. Of course, not is online. It is a different thing, face to face, different thing. The thing can be expressed in better manner. Okay, thank you very much. Hello,
Thank you, sir, for the wonderful session. Hello.
hello. Yes, thank you very much.
Thank you,
Hello,
sir, for the wonderful session.
welcome, welcome. So can we stop it now here?
पार्टिसिपेंट्स के पास
हाँ.
कोई क्वेश्चंस हो तो वो पूछ सकते हैं सर से प्लीज.
Hello, hello.
Yes.
Yes, I think nobody is speaking.
Yes, sir.
हाँ.
Okay, sir. I would
So
like to
tomorrow.
thank Dr. Shriramji Girija Shankar Jyotishi sir for enlightening us on the knowledge. Today webinar was full of knowledge about the variability, type of variability and its role in Ayurveda and statics, how to measure it and probability, define laws and role of it in research field with proper examples. And lastly, thank to all the participants on the behalf of Panchakam department for their patience in listening this webinar. Tomorrow will be continue the rest part of this lecture, that is parametric and non-parametric test. Thank you everyone and thank you so much sir.
Thank you. Welcome. So we'll meet tomorrow again with the test of significance, parametric and non-parametric.